Welcome to our video tutorial of inductive reasoning. Now, this is our first ideas with inductive reasoning, so it might get more complicated. Keep that in mind, but please be attentive to these basic ideas. Here's our first problem. Determine a rule for the sequence. And what we mean by that is, at the end of the problem, we want to find out what a sub n is equal to. A sub n is just the number in the sequence, the nth number in the sequence. We want an algebraic expression in terms of n for the value of the nth term in the list. Now, when we worked with algebraic expressions back in Algebra 1, we used a t-chart quite often. So that's what we're going to break out first here, a t-chart. On the left-hand side of the chart, we're going to put the letter N as the title. On the right-hand side of the chart, we're going to put A sub N as the title. The left-hand side, the values of N, are just which item in the list are we talking about. The A sub N is what that item in the sequence actually is. It's simple. The first item in the list is 152. The second item in the list is 153. The third item in the list is 154. The fourth item in the list is 155. The fifth item in the list is 156, and our goal is to figure out an algebraic expression for the nth term in the list. A way for us to quickly generate the 20th term, or the 40th term, or whatever term we're interested in. Now, when we discussed this in class, we said on that left-hand side you might end up multiplying, dividing, adding, subtracting, or doing other creative things to get the right-hand side. But what you want to do is figure out what happens to n in order to generate a sub n. What happens to the left-hand side of the chart in order to generate the right-hand side of the chart. This one, hopefully you see it. If we add 151 to 1, we get 152. Adding 151 to 2, we get 153. Adding 151 to 3, we get 154. Adding 151 to 4, we get 155. And adding 151 to 5, we get 156. So in this problem, it looks like we're adding 151 to the item on the left in order to get the item on the right, which means that our rule for a sub n is that we take n and we add 151. And that would be our final answer. Now, as we also mentioned in class, here's a nifty way to watch for when you're adding or subtracting by a single value. Look at the numbers in the list themselves. They're going up by 1 each time. And when that happens, this is always going up by 1, the items in the list. When that happens, watch for this first approach. See if there's a number that you can add or subtract to the left-hand column, the value of n, in order to generate the right-hand column, the actual number in the sequence. Next problem. Second of 3 problems we're looking at. We want to determine a rule for this sequence. Now, of course, you can hit pause and see if you can figure it out on your own before continuing this video. But the first thing I notice is that the numbers get really, really big, really, really fast. And when that happens, in class we said to watch for multiplication. So we're still starting off with our t-chart, values of n on the left, the actual numbers in the sequence on the right. Again, this means our second term is 64. The fourth item in the list is 4096. But since they're going up pretty quickly, let's watch for multiplying. 8 times 8 is 64. 64 times 8 is 512. Have your calculator handy if you need to verify some of this. 512 times 8 is 4096. And I believe 4096 times 8 is 32,768. But now, the profound statement of this video, 8 is equal to 8. For 64 then, we took that 8 and we multiplied it by 8. For 512, we took what we had and we multiplied by another 8. Take what we have, multiply by another 8. So there's going to be 4 of them multiplied together for 4,096. And for 32,768, we'll take what we had and we throw another 8 into the mix. So look here. Now we're trying to simplify to get a nice algebraic expression. 8 is simply 8 to the first. 8 times 8 is 8 squared. 8 times 8 times 8 is 8 cubed. Well, when there's 4 of them multiplied together, that's 8 to the fourth. And with 5 of them multiplied together, that's 8 to the fifth. Keep in mind what we're trying to do. We're trying to take the left-hand side of this t-chart, the values of n, and use those to generate an algebraic expression for the right-hand side of our t-chart. Well, now on this one, it isn't too bad. A sub n is just going to be 8. It's always an 8. Look down the list there in red. And the exponent is just the value of n itself. So we have a sub n is equal to 8 to the n. Whenever you're multiplying by a number consistently throughout, watch for this approach. Again, this is our first introduction to inductive reasoning, but keep the idea in mind. Now for our third and final problem in this tutorial. Again, I might encourage you to try to solve this and pause the video and then see if you got it correct. First thing we're going to do is make a t-chart. There it is. The items on the left are the n's. The on the right hand side is the a sub n. This is saying our third item in the list is 40. Our fifth item in the list is 70, and so on down the line. Now, notice, as we discussed the previous problems, if I were adding the same number every time, that's not going to work. First, 18 plus 10 is 28. Then 28 plus 12 is 40. That's not going to get us anywhere. We're not multiplying by the same number each time unless we want to deal with fractions, and I don't even want to look at those fractions. So our first two ideas don't really work. In class, I stressed to watch for these three ideas. So keep this last one in mind. It's really important. In fact, I'm going to put a star up here because it's important. Watch for splitting the numbers in the list into the product of two numbers. So for example, 18 is 2 times 9. That's a start. 28. I'm going to write that as 4 times 7. 40. I can write as 4 times 10. 54. Let's go with 6 times 9. I think that's 54. And 70, I'm going to go with 7 times 10. Now, our goal is that hopefully we see a pattern just jump out and be clear as day to us. Unfortunately, no. Now, I do see a little bit of a pattern here that I like. So let's backtrack. Let's redo this one here. Can we write 40 as something where this pattern continues? 40 is 5 times 8. I like that. Now look above. Then we got the 4 times 7. Notice we've got a pattern. 4, 5, 6, 7, 7, 8, 9, 10. The first item doesn't fit. Let's get rid of it. Is there another way that we could write 18? Well, yeah. 18 is 3 times 6. Now we have a nice pattern. Take the n on the left, and we're trying to figure out how can we generate the right-hand side based on those values of n on the left. In this case, we've got two numbers that are being multiplied together. So there's going to be two components to this rule. A sub n is going to end up being something times something. Make sure you've got the parentheses around the somethings. Look at one of them at a time. So let's focus in on the blue. How do we go from the values of n that we have highlighted in yellow to those blue numbers on the right? We're adding 2 each time. So we're taking the n and we're adding 2. In that set of parentheses, we'll put n plus 2. Then, how do we take the number n on the left and generate those numbers in purple or red on the right? It does look like we're adding 5 each time. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. So to get the number that we're putting in this set of parentheses right here, we take the n, we add 5, that's going to be n plus 5. There's our final answer. A sub n is equal to n plus 2 in parentheses times the quantity n plus 5, also in parentheses. This is a really big idea. It could pop up on a quiz or a test. Watch for splitting a number in the sequence into the product of two other numbers, and then seeing a few different patterns that combine to make our overall rule. Thank you for watching Inductive Reasoning.